Welcome back to another day of Trigonometry 101. Yesterday we learned how to solve for a missing side of a right triangle with trig. Today we learned how to solve for a missing angle using trig. So, quick review. Trig ratios. SOHCAHTOA is a mnemonic device to help us keep straight which ones are which. We note that for all three of the trig ratios, all three of the trig formulas, that we're doing sine, cosine, or tangent of an angle. The angle is always the input for the trig function, and it's always equal to a ratio of two sides. So angle goes on the left side of the equation with the trig ratio name, and the sides go together on the right side of the equation. So today we learn how to solve for this missing angle x, or a, or p, or q, or w, or whatever its name is. And that requires that we use what we call the inverse trigonometric functions. Inverse is that fancy word that we learned in algebra for undo. It undoes things. So we have all sorts of inverse operations in mathematics. We have addition, subtraction. So if we add 12 plus 13, we get 25. If we do the inverse operation, 25 minus 13, we get 12. So addition and subtraction, they undo each other. Multiplication, division also undo each other. You start with a number 3 and you multiply it by 5. You get a 15, and then you take 15 and divide it by 5. You do the inverse operation. It takes you back to the 3 you started with. We've been using inverse operations since early elementary school when we learned that addition and subtraction are sort of two sides of the same coin. One will undo the other. Those are inverses. When we get beyond add, subtract, multiply, and divide, on our calculator, typically things that are inverses of each other are on the same key. So over on the left side of the calculator, where we have several new types of functions or buttons, the inverse operations are typically on the same button. For example, if we look beside the 4, we have a button for x squared, and a square root is its second function in blue above the key. So if I take a number, say 5, and I square it, and the difficult thing here is you can't see the screen at the same time. Well, actually you can, but the sun is being really, really brutal right now. Let's see if we can make that better. Not much. That's really difficult to look at. Let's see if I can find a less. Man, that's difficult. Okay, there. That's a little bit better. So let me back up. So I'm going to just pick a number, 5, square it, and hopefully we know that that's a 25. And then the second function will take the 25, the answer, and if we do square root, we got to do square root button first. Square root of 25, it'll take us back to our original input of 5. So squares and square roots are inverses of each other. There are other keys here that work the same way. Beside the x squared, you have this caret key. That's your power raising key. If you take 8 to the third power, that's 512. If you use the inverse key, which is this nth root of x, that second function on the same key, control nth root, and you use a cube root instead of a cube, you use a cube root of the answer, 512, it'll take you back to the 8 that you started with. So a cube and a cube root are inverses of each other. And there are other examples. We have some logarithms down here on this third row of keys, and the ln and the e to the x, those will undo each other. Those are inverse operations. And log and 10 to the x power, those are inverse operations. Those are some keys that you would use in science classes when you deal with things like growth and decay of natural things, elements, and just any kind of carbon-based living things are governed using those tools. Well, the trig functions are really not any different. In trig world, everything has an inverse as well. You have to have an undo button. And so what is the undo button? Well, all the trig stuff is on the same key, this trig key right here. So let's take a look. So on the trig key we have in the top row sine, cosine, tangent, which we're familiar with. These other three, they're called cosecant, secant, and cotangent. You would learn those in a more advanced trig course. We typically use those quite a bit in pre-calculus, where we learn some heavier trig. But you'll notice in the row under those, you have those same 6 functions with these little negative ones that look like exponents. They really aren't actually exponents. That's actually an inverse symbol. So we would read this as the inverse of sine, inverse of cosine, inverse of tangent. Okay, so inverse of sine will undo sine. Inverse of cosine will undo the cosine. And inverse of tangent, and it doesn't have its own name. We just stick the word inverse in front of it. So we usually call this inverse tangent will undo a tangent. So I want to show you what I mean by that. So let's take the sine of 30 degrees. Okay? So if I compute the sine of 30 degrees, still having a hard time with the glare, that is, on my calculator, 1/2. On your calculator, it would be a 0.5, which is the decimal equivalent. If I use the inverse sine command, so trig, and the inverse sine, which is sine with the -1, and then I put in 1/2, so I put in the answer that I got here, and press enter, it's going to give me back 30 degrees. Oh my, I'm just a big old mess today. So that's your undo button. The same thing's going to happen for cosine. If I do cosine of, let's say 30 degrees again. Well, now let's do 45. Let's do another special case. My calculator says it's the square root of 2 over 2. Yours is going to say something like 0.7071 blah 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 blah, some long decimal approximation. If I do the inverse cosine of the square root of 2, whoa, oh goodness, wrong button, Miss Rice, square root of 2 over 2, it should hand me back the 45, which is exactly what it does. So inverse cosine is the undo button for cosine. And we need undo buttons when we solve equations because undo buttons are what allow us to undo operations and get x on a side by itself, which is what we have to be able to do today. So that's the calculator version of what we need to know. So let's get back to the actual pencil paper setup and solve trigonometry. So we'll move on to this example, and we see it's another right triangle problem where we want to solve for a missing part, but this time that missing part is the angle. X is an angle. I know it is because there's a degree symbol right there. So this angle right here, this corner, the bottom left hand corner, is unknown, some unknown degree measure. And I'm trying to figure out how big that angle is. I know 2 sides, and that's the only other information that I have other than the right angle, which isn't particularly useful in a formula. So definitely not a Pythagorean theorem question because Pythagorean theorem only solves sides. It doesn't look like a special case because I don't see any square roots of 2s or square roots of 3s floating around. So this is a trig question. So I started the same way I started the trig questions that we did yesterday with SOHCAHTOA. SOHCAHTOA. And I want to figure out what pairs of sides I'm working with respect to this angle X that I have labeled down here. So using that for reference, across the triangle from it is the side that's 24 units long. That's got to be the opposite side. 29 is opposite the right angle. That is a hypotenuse. And so I'm working with opposite and hypotenuse. O and H go with the sine function. So I'm going to use the sine function here. I have a formula for that. This says sine of an angle equals opposite over hypotenuse. And then I need to stick some numbers in. So the difference between what we did yesterday and what we're doing today is now the missing number is on the left side of the equation rather than the right side of the equation. That unknown angle is actually this unknown degree measure x. So the x goes on the left side with the sine. It's in an understood set of parentheses. We don't have to write that on paper, but typically that's how the calculator would make us look at it. Opposite is 24. Hypotenuse is 29. So step 1 is the setup. That's exactly like we did before. The only thing that has changed is where the x is. The x is not on the right side in the ratio. The x is now on the left side. So the solving is going to change. The good news is this is the easiest one of all to do. It's the least work. The goal is to get an x on a side by itself. Alright, so step 2 is to get x alone. And in order to do that, you have to use an inverse. Because the goal is to make sine go away so that x is left behind. And this is not multiplication. This isn't sine times x. This is sine of x. We're doing something to the angle x. Not multiplying though. So to make sine go away, we actually have to take the inverse sine of both sides. So what does that look like? Well, it's kind of like we did in the Pythagorean theorem section where we took the square root of both sides, but it looks a little bit uglier. So what we do is we take the inverse sine, that's not the color I wanted, inverse sine of the left side, and we take the inverse sine of the right side. And because we want to use correct notation, the inverse sine is it's like a square root symbol. It just has letters instead of little straight lines that are put together in a weird conglomeration. We're taking what we had in the step before and applying an inverse sine to both sides. So what happens on the left side of the equation is inverse sine cancels the sine. Those are undo buttons. Okay? That leaves just an x. All those parentheses go away. We don't need them anymore. X is now on a side by itself. Okay, so we just got x alone on a side by itself. The other side, we want to find the inverse sine of 24 over 29. That's a calculator operation. The calculator will find that missing number for us. So let's take a look at the calculator one more time. And we're going to go to the trig key. And we need the inverse sine command. We're going to put it in just the way it looks. So inverse sine command, and I'm going to do control fraction and put 24 over 29. Goodness, the glare is terrible. And that is approximately 55.9 if we round up degrees. So 55.9 degrees. Which is reasonable looking at the picture. So really you can do this in 3 steps. Set up, take an inverse of both sides, and then do the number crunching in the calculator. They're all, no more, no less. The same number of steps every single time, same steps every single time. So I should probably write down here, step 3, use your calculator. Now, what I did not do in advance, and I may regret this, is I did not play with this calculator. So I noticed that I have a sine, cosine, and a tangent key, but I don't have any inverse keys on this calculator. What am I going to do? So this, I notice I'm on like the main page or the main screen, the main buttons. There's also an ABC option. If I click on it, it's going to give me an actual keyboard if I needed to type in anything, including a pi symbol down here that might come in handy later. But there's also this third option. It looks like the abbreviation of the word function. Trig ratios are functions, or trig things are functions. If I click on that, ta-da, I get all this extra stuff that wasn't there before. So I get some of these keys, like I have on my graphing calculator, that I don't really use a whole lot, but the really cool thing is I get the sine, cosine, tangent, and also the inverses. So to get to the inverses, you have to be on that page. Okay, so what did I need? I needed the inverse sine, so click on inverse sine. I need a fraction. Okay, I don't see a fraction template here, so we're going to go back to the main page, so click on main. And fraction keys over here, so insert a fraction. And on the top we had a 24, and on the bottom we had a 29. So now it looks exactly like it did on my handheld calculator. And I'm already seeing the result here even before I press enter of 55.9 if you round up. So you do have the appropriate tools on this machine, you just have to push an extra button to get to them. Alright, so the worst is over. Let's do a couple more examples and we will be done for the day. So let's take a look at this one. Again, note we're solving for a missing angle. Because the X has a degree symbol on it, that means we're looking for the angle measure of this acute angle down here in the bottom left-hand corner. With respect to that angle, 9 is the adjacent leg. It attaches X degrees to the right angle. So 9 is the adjacent. 20 is opposite the right angle. It's the hypotenuse. And so TOA tells me that cosine goes with an A and an H. So this is a cosine problem. So I'm going to use cosine of an angle equals adjacent over hypotenuse, and then stick some numbers in. So cosine, the angle is the unknown X, so leave that X, equals, adjacent was the 9, hypotenuse is the 20. Sets up just like all the other trig equations did. The only thing that's changing is how we solve it. So the goal is to get X on a side by itself. Now what I would normally do instead of copying the whole thing down again is I would just go ahead and take the inverse cosine of both sides, because that's the undo button for cosine. So on the left, I'm going to take the inverse cosine. On the right, I'm going to take the inverse cosine. So we're just going to squeeze it in there so that I don't have to recopy the whole thing. So we're kind of crunching two steps together. So this is steps 1 and 2, which is the setup and take the inverse. And that's going to save us some work. That means it becomes a two-step problem, setting it up and putting it in the calculator, as far as how many steps you have to write down. Now on the left side, inverse cosine, cosine, those are inverses. They cancel each other out. They undo each other. X is left behind, so bring down an X. That's about equal to whatever the inverse cosine of 9 over 20 is. So on our Inspire, we're going to need to go to the trig key, click on inverse cosine, and you don't actually need a fraction template here if you don't want to. You could just do 9 divided by 20, and it's still going to straighten it up and make it look pretty when you press enter. Oh, oops, I needed to press an extra button on my machine. I'm getting about 63.3 degrees. So about 63.3 degrees is the angle measure. So note that if you don't have to copy down the equation without the numbers in it, it's really just a two-step problem. So very short, it's never longer than that. It's 2 steps every single time. Now if you have the other calculator, let's take a look at it again. To get that inverse cosine function, we have to go to this third screen, FUNC, the extra functions. Click on inverse cosine. and type in 9. Oh, got to go back to the main to get numbers. Main. 9 divide by 20. And see how pretty that is? It made it look like a fraction all by itself. And that's about 63.3, which is the same thing we got with the other machine. Alright, let's do one more problem just to make sure we've got it. Alright, we have an unknown angle, x degrees, right here. With respect to that, 17 is the opposite leg. 11 is a leg that's attached to x degrees, and it stretches from x degrees over to the right angle. It's a leg. That means this is the adjacent leg. Hypotenuse is useless. We don't know what it is. We know SOHCAHTOA. And O and A go with tangent. Now let's just go out on a limb here and skip straight to the numbers. Okay? See how short and sweet this is if we skip straight to the numbers. T is for tangent. The angle is x. The opposite is 17. Adjacent is 11. Tangent of an angle is opposite over adjacent. Okay, we have it set up. The goal is to get the tangent to go away so that x will be on a side by itself. So we're going to take the inverse tangent of both sides. So we take the inverse tangent of the left side, and we take the inverse tangent of the right side. Just squeeze that in there. On the left side, the inverse tangent and the tangent cancel each other, leave an x. On the right side, we have some calculator work to do. So I'm going to skip straight to our little Desmos calculator this time. And let's go to our function menu. Click on inverse tangent. Go back to our main menu for some numbers. And I've already forgotten what my numbers are. 17 over 11. Okay, so 17 divided by 11. And that's 57.1 if we round. So x is about 57.1 degrees are our units. Okay, so that's it for today. Pretty much they all look the same. You just have to make sure you're using the correct trig ratio when you set it up. So you're going to do page 17 of your practice packet. Problems exactly like these for some extra practice. And do the homework check quiz on Schoology. And that will leave us with one last short lesson tomorrow. One last page of practice problems before we're ready to review for a test. So tomorrow we'll dig into some word problems, just a couple of them, talk about some vocabulary related to those, and wrap this chapter up. Alright, have a good day.